Hello and welcome to Mr. Muckleburgh's Maths World. This is the way it is. Completing the square part 2. Now obviously not all quadratic equations have a coefficient of x squared set to being 1. Here's the case in point. A is equal to 3, isn't it? So, and also the other thing you might want to check before you try to solve an equation is in fact that it does have a solution, or two solutions, 1 or 2. And we know that we can use the discriminant to ascertain how many solutions there are to a question. The discriminant, discriminant is equal to b squared take 4ac. Okay? That's going to tell us how many solutions there are. Let's have a look. So b in this case is negative 4. So it's negative 4 all squared minus 4. A is 3. There's A there. And C is 1. So that's quite clearly greater than 0. I'm expecting there to be two solutions to my equation. So completing the square is an appropriate method to use. Okay. Now, when the coefficient of x squared is not 1, there's something you've got to do beforehand. And that is divide the equation through by the coefficient of x squared. That's what makes these ones a little bit messy. You've got to divide the equation through by the coefficient of x squared. Okay? Because we need it to be 1x squared. Alright, so doing that, we can say that our equation is now equal to x squared minus 4 on 3x plus a quarter, and of course 0 divided by anything is 0. A third. I'm dividing through by 3. Okay? But from here on in, it's the same technique we employ. So we're halving the coefficient of the middle term, x, squaring it and adding it to both sides. So in this case, we go like this. X squared minus 4 thirds x plus. Now, when you halve a fraction, that's the same as doubling the denominator. So it's not so bad. In fact, I could have done it easier by just halving the numerator. That's the other option. I should have done that. So, but I didn't, so we'll proceed. Now what I do to one side, I must do to the other. And that is add my negative 4 times 6 all squared. Okay? Alright. So, proceeding, we get a perfect square form in here, and it is x. Can we agree that that is equal to negative 2/3?
Yes.
Okay. So, I'll fix that up now. And then I'm going to take the positive 1/3 over to the other side and tidy this up at the same time. Equals negative 2/3 squared minus 1/3. Okay, what am I going to do now? Well, I'm going to tidy up the right-hand side and leave the left-hand side as you see it. Now, what have I got here? I've got anything squared, remember, is positive, so it's 4 over 9 minus 1/3. Okay? Up over here we go, and we find that I'm still going to tidy up the right-hand side a bit more before I take the square root of both sides. And I'm going to convert this to 9. So to do that, I'll times that by 3, times that by 3. So it's 4 minus 3 on 9, and that's obviously equal to 1/9. That's quite nice. So x, now I'm going to take the square root of both sides, equals plus or minus the square root of 1/9. And then this is quite convenient, I hope you notice, because the square root of 1 is 1, the square root of 9 is 3. So it's just equal to 1/3 plus 2/3. And therefore, x is equal to, let's write it out like this, I think, 1/3, or plus 1/3, plus 2/3. That's equal to 1, isn't it? Yeah. Or it's equal to, or or, so there's two possibilities, x equals negative 1/3 plus 2/3 equals 1/3. Therefore, now let's summarise this before we lose track of things. X equals 1 or x equals 1/3. Okay, now we should be able to check our answer quite easily by substituting either value into our equation, and it should equal 0. Okay, let's just do a quick check. 3 times 1, what am I doing? 1 squared is 1, so 3 minus 4 is negative 1 plus 1 equals 0. Seems to check out, and it will check out presumably if I substituted 1/3 in as well. Okay, so that's completing the square, a more complicated example.